All right, so up until this point, we've been dealing with all of these identities, right? And we've got the whole rest of this page. So we're going to do all the rest of the page today. And so I'm going to show you the proof, and then I would tell you that the easiest thing to do is just memorize the sum and difference and the double angle identities, and then you don't have to worry about the proof. Now you do need some data that's in here. So this is blank on the back, so I'm going to have you flip it over, and I'm going to do the proof, and then I'm going to give you the cheat up here, okay? So the first one that we have is sine of 2x. So that's the first identity you have here, and it's the double angle identity. And so what I really have on this double angle identity is going to be sine of 2x's. So it's going to be x plus x. All right. So now for me to finish this, I'm actually going to pop down here to the addition and subtraction identities. And so these addition and subtraction identities, I'm going to give you a couple of little hints over here, and then I'm going to go in and do the proofs, and then we'll go back and finish double angle. All right. So when I have this sine and cosine, if I'm dealing with sine, I want you to think that the sign, S-I-G-N, is the same. So what I know already is that if this is addition, then this is going to be addition. And if this is subtraction, then this is going to be subtraction. So sine, the sign is the same. Okay? So for cosine, the sign is going to change. So one way to think about this is this begins with a C and this begins with a C. So my sign for cosine is going to change. So if this is addition, this is subtraction. Okay? And if this is subtraction, this is addition. All right, super important as we go into these identities that you see how the signs for sine are the same, the signs for cosine are going to change. Okay, so this is just kind of a little sing-songy thing. It's just, I'm not going to actually do the proof. I'm just going to show you how this works. So when we deal with sine, we say that the sine is going to go to the x, and then sine is going to go to the y, but not on the same side of the equation. So I'm going to write this as sine, cosine, cosine, sine. And you see I didn't put any variables in here. I didn't put the x and the y in first. So I said sine, cosine, cosine, sine. Now, I could have said sine, cosine, and then sine, cosine again, but the logic behind this, sine, cosine, cosine, sine, is now I fill in my variables. So if this is my first variable and this is my second variable, I would say x, y, x, y. So what you'll hear me say over and over is sine, cosine, cosine, sine. And then down here for cosine, my little sing-songy thing is cosine, cosine, sine, sine. So for sine, sine, cosine, cosine, sine, I come down here, cosine, cosine, sine, sine. So again, I go fill out my variables next. So x, y, cosines change, so it's negative. So this is going to be the same thing. Sine, cosine, cosine, sine. This is an x, this is a y, this is an x, this is a y. So the only thing that's changed between these two things is that this is addition and this is subtraction. So for cosine, I have cosine, cosine, sine, sine. Then I go in and add x, y, x, y. All right, so with that being said, right, here are my addition and subtraction identities. We can go back in here and look. And so for cosine, I see cosine, cosine, change, so it's subtraction, sine, sine. And then I went back, alpha's first, beta second. Alpha's first, beta second. Same thing here, cosine, 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 sine, sine. I'm adding alpha's first, beta second. All right, with sine, sine, cosine, cosine, sine. And y'all, just the sing-songy thing just sticks in my head. If that doesn't work for you, just remember sine is both Cosine is the same on both sides. Okay? All right, so now I'm going to use this strategy with my double angle theorem. So go ahead and flip it back over. So now what I have is I have sine x and plus x. So sine of 2x's is the same as x plus x. I have two of them, right? So this is an addition. This is the same as this, sine of x plus y. It just happens that they're both x's. So I know with sine, I have sine, cosine, cosine, sine. My variables here are x, x, over here, x, x. Sine is the same sign, so it's positive. Okay, so I know there was a lot going on, so let me do this one more time. So my sing-song formula for addition, for my sum identity, which is adding, is sine, cosine, cosine, sine. It's just the order that it has to be in. This is x, over here, this is my first x, and this is my second x. Now, this is multiplying, so the order can be reversed, the order can be changed. So when I simplify this, what I end up with is 2 sine x cosine x. And that is my identity. So over here, my identity for this is 2 sine x cosine x. So when we see this, we can substitute it for this. These two things are equivalent. All right? So now let's go do the proof for cosine. So if I have cosine of 2x, this is my double angle theorem. I have the same thing as cosine of x plus x. This says I have two of them. All right? So my little sing-song for cosine is cosine, cosine, sine, sine. So cosine, 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 sine, sine. My variables are x, so this is my first one. This is my second one. This is my first one. This is my second one. Okay? Now, remember, the sign, S-I-G-N, sine on cosine changes. So, because this is adding, this now becomes subtraction. All right? And that is really important for this next step. So, as I simplify this, I now have cosine squared x minus sine squared x. Now, this is my first double angle theorem. So we're going to write that down over here. Cosine squared x minus sine squared x. Don't get this confused with your Pythagorean idea of cosine squared plus sine squared, right? Doesn't work. So cosine squared minus sine squared is the same as this. All right, now you see I've got two other ways that I can write this, two other ways you can see this. And this brings in my Pythagorean ID. So I have sine squared plus cosine squared equals 1. So if I convert this, then I'm saying here that this cosine squared is the same as 1 minus cosine squared x minus, oh, sorry, I didn't want to do that. It's 1 minus sine squared x because I'm converting cosine. So cosine becomes 1 minus sine squared x minus sine squared x. All right, so both are negative, so this is the same as 1 minus 2 sine squared x. That's my second way I can see this formula. Now, don't get this confused with up here. So my 2 here is with my x. The 2 here is out front. I have 2 sine squared x's in there. Okay? Now, when I do this, this makes it so that I cannot use, this is no longer a difference of squares. So this is not a difference of squares anymore. In that last unit, we used difference of squares, but that's not what this is anymore. All right, let me do my last one. So my last one, I'm going to bring this down here. Here, I converted everything to sine. This time, I'm going to convert everything to cosine. So I have cosine squared x. That's my first one. And now when I use my formula, I have minus 1 minus, why do I do that today? 1 minus cosine squared x. So I distribute this negative through. So cosine squared x minus 1 plus cosine squared x. So now I have 2 of them. All right. So if I come over here, my last one is 2 cosine squared x minus 1. You'll notice that the order is backwards. The order's different on this. It's super important. It's super important. I mean, if you made this 1 minus 2 cosine squared x, that would be wrong. So the order is really important. You see these identities here on your double angle theorems down here, right? So these are the ones that we just proved. If you remember them, you don't have to go back and reprove them, right? Remember, you don't get the cheat sheet on your test. So it's important that you see those, all right, that you remember those. So put them on a note card, or you can always prove them. If you remember the addition and subtraction identities, then these are easy. Okay, good news. In on-level pre-cal, we are not going to cover the half-angle identities. So I know that those are on your worksheet down here, but we're not going to worry about those. Okay? Let's practice.